In this module, we will discuss the air conditioning system. We will start with the system description and follow with a discussion of the associated controls and indicators. Next, we will discuss normal procedures, and we will conclude with a discussion of some abnormal system operations. The air conditioning system consists of a left and right pack. They convert pneumatic air into conditioned air to maintain selected temperatures throughout the aircraft. A ventilation system provides equipment cooling as well as increased ventilation rates throughout the cabin. Air from a ground air conditioning cart can also be used to cool the airplane. The ground cart connects directly to the mixed manifold. We will now start with a description of the air conditioning packs. The air conditioning packs convert hot, high-pressure pneumatic air into conditioned air. The sources of air for the air conditioning system are the engines, the APU, or ground pneumatic cart. Hot engine bleed air flows through the pack valve and passes through a heat exchanger. This heat exchanger is located in a tunnel within the bottom side of the fuselage and is cooled by slipstream air. This slipstream air enters the heat exchanger tunnel through movable ram air doors. After flowing across the heat exchanger, the ram air exits through the ram air outlet located aft of the heat exchanger. In flight, the ram air doors modulate open or closed to provide the required airflow for cooling. When the flaps are extended in flight, or when the aircraft is on the ground, or any time maximum cooling is required, the ram air doors are fully open. The ram door full open light on the air conditioning panel illuminates. When the aircraft is on the ground, the air cycle machine pulls air through the heat exchanger using an impeller fan. After flowing across the heat exchanger, the ram air is expelled out of the ram air exhaust. The air ground safety switch opens the deflector doors when the aircraft is on the ground. After passing the primary heat exchanger, the pneumatic air enters the air cycle machine for refrigeration. The resulting cold air passes through a water separator which extracts moisture from the air. This conditioned air is routed to a mix manifold where it is mixed with the output from the other pack and enters the distribution system. The pack output temperature is modulated by mixing it with some hot bleed air prior to the water separator. This air is tapped after the pack valve and flows through a pack temperature control valve. In addition, there is a standby pack temperature control valve. Bleed air from the pack temperature control valve or the standby pack temperature control valve is mixed with the output of the air conditioning pack prior to the water separator. From the water separator, the conditioned pack air flows to the mixed manifold. The pack temperature control valve is controlled by an associated electronic controller. The electronic controller modulates the opening of the associated pack temperature control valve to achieve the desired pack output temperature. This electronic controller incorporates a primary and a standby controller. In the event of a failure of the primary pack control, the affected pack will be controlled by the standby controller in the opposite electronic controller. In this situation, the opposite standby controller will modulate the standby pack temperature control valve on the affected pack to achieve the desired temperature output. A failure of the primary pack controller is indicated by the illumination of the pack light, the master caution light, and the air conditioning system annunciator light during a recall. In the event both the primary and standby controllers fail, the affected pack will continue to operate without control. This situation will cause the pack, master caution, and air conditioning system annunciator lights to illuminate. Even though the pack is operating without control, an excessive pack temperature will cause the pack to trip off. The pack output is supplied to a mix manifold. In addition, a ground air conditioning unit can be connected directly to the mix manifold. From the mix manifold, the conditioned air is distributed throughout the aircraft. The left pack normally supplies air to the flight deck. Since the flight deck only requires a small portion of the air produced by the left pack, most of the conditioned air from the left pack is supplied to the mix manifold. The right pack supplies all of its conditioned air to the mix manifold. Air from the mix manifold is supplied to an overhead distribution duct through the side wall risers located on the left and right wall of the passenger cabin. The overhead distribution duct distributes air to the cabin through diffuser outlets. The distribution duct extends from the forward to the aft end of the passenger cabin. The B737-800 incorporates two recirculation fans. The recirculation fans draw cabin and E&E compartment air into the mix manifold through an air filter in the forward cargo compartment. This improves ventilation rates and reduces air conditioning pack load and bleed air demand. The end result is a reduced fuel consumption. Each recirculation fan is controlled by an associated recirculation fan switch. The recirculation fan will operate only if the associated recirculation fan switch is in the auto position. Click on the left recirculation fan switch to place it in the auto position. In flight, the left recirculation fan operates provided the associated recirculation fan switch is in the auto position and both packs are operating. However, in this situation, the left recirculation fan will stop if either pack switch is operating in high. On the ground, the left recirculation fan will not operate if both pack switches are selected to high. In flight, the right recirculation fan will operate if both packs are operating unless both pack switches are selected to high. On the ground, the right recirculation fan operates even if both pack switches are on high. We will now discuss how the temperature is controlled throughout the airplane. The aircraft is divided into 3 zones. These zones are the flight deck, forward, and aft cabin. The zones are supplied conditioned air by ducts extending out of the mix manifold. Zone temperature control is achieved by adding hot bleed air. This bleed air is called trim air. The output temperature of both air conditioning packs is dictated by the lowest requested zone temperature. Trim air is tapped from the pneumatic system prior to the pack valves. Both the left and right sides of the pneumatic system supply bleed air to a common trim air supply duct. Trim air flows through a trim air pressure regulator and shutoff valve. The trim air switch on the air conditioning panel controls the opening and closing of the trim air pressure regulating and shutoff valve. The temperature for a zone is adjusted by adding trim air. The amount of trim air added to a zone's distribution duct is controlled by an individual trim air modulating valve. Since the zone requiring the most cooling determines the pack output temperature, that zone's trim air valve will normally be closed. In the event of an excessive temperature in a zone's trim air supply duct, the associated trim air modulating valve will close and the amber zone temperature light illuminates. The trim air modulating valve can be reopened after the duct has cooled by pressing the trip reset switch. The left electronic controller controls the operation of the trim air modulating valve for the aft cabin zone. It also provides backup control for the flight deck zone. The right electronic controller controls the forward cabin zone and provides primary control for the flight deck zone. Zone temperature is controlled by the individual temperature selectors located on the air conditioning control panel. Each selector allows the selection of a temperature between 65 degrees Fahrenheit and 85 degrees Fahrenheit. If all zone temperature selectors are placed in the off position, the left pack will produce a fixed temperature of 75 degrees Fahrenheit and the right pack will produce a fixed temperature of 65 degrees Fahrenheit. The controls and indicators for the air conditioning system are located on the overhead panel. Each pack is controlled by a 3-position switch: off, auto, and high. With the pack switch in the off position, the associated pack valve is closed. Click on the left pack switch to place it in the high position. Positioning a pack switch to high causes the pack valve to increase pack output to a high flow rate. High flow is used when additional cooling and ventilation is required or when additional volume is required for pressurization. If the APU is supplying air to the packs while on the ground, positioning one pack switch to high will automatically cause the APU to provide high flow. APU high flow provides a higher volume output than normal high flow. Such a configuration with both packs set to high will produce the maximum possible flow rate. Click on the left pack switch to place it in the auto position. With the pack switch in auto, pack flow rate is controlled by a system which selects the flow rate depending on pack switch position, air ground logic, and flap position. In auto and both packs operating, each pack regulates to low flow rate. With only one pack operating when in flight with the flaps up, pack flow rate is regulated to high. When operating one pack from the APU, the pack will switch to the high flow mode when both engine bleed switches are off. This is normally what happens during a bleeds off takeoff. The pack light monitors internal pack temperatures and the status of the associated primary and standby pack controller. Excessive internal pack temperatures will cause the pack valve to close and will illuminate the associated pack light. A failure of the associated primary and secondary pack controllers will cause the associated pack temperature control valve and the standby temperature control valve to close. In this situation, the affected pack will continue to operate without any control. However, an excessive pack temperature will cause the pack to trip off. When both the primary and standby controllers fail, the pack light, both master caution lights, and the air conditioning annunciator lights will illuminate. The temperature selectors are used to set the desired temperature in the cockpit and the forward and aft passenger cabins. The temperature selectors have two types of settings: automatic and off. With the temperature selector in the auto position, The temperature in the associated zone of the aircraft is automatically maintained by a temperature controller located in the electronic equipment bay. The temperature selectors provide commands to their corresponding temperature controller. Each temperature controller controls the corresponding trim air modulating valve. The temperature controller receives temperature information from sensors located in the ceiling. Placing the temperature selector in the off position will close the associated trim air modulating valve. Air conditioning output temperature is monitored on the temperature indicator. The source to be monitored is selected by the air temperature selector. Selecting the supply duct position monitors the left cabin supply duct, while the forward and aft positions monitor the passenger cabin supply ducts. Due to the heat generated by the flight instrumentation system, fans provide additional ventilation for the display units, forward and aft electronic panels, circuit breaker panels, and the E&E compartment. One fan, called the supply fan, ducts passenger cabin air around the flight deck displays and the electronic equipment in the E&E bay. The other fan, called the exhaust fan, draws air from the flight deck displays, the overhead and aft electronic panels, the circuit breaker panels, and the E&E compartment into the exhaust ducting. Each fan has an alternate. Together, these fans are controlled by the equipment cooling supply and exhaust switches. The normal fans are powered by main bus number 1, and the alternate fans are powered by main bus number 2. Depending on air-ground logic, this air is either exhausted overboard or into the forward cargo compartment. The direction of flow is controlled by the overboard exhaust valve. On the ground or in flight, when cabin differential pressures are below 2 psi, the exhaust fan air is exhausted overboard. At greater cabin differential pressures in flight, the overboard exhaust valve directs the air to the forward cargo compartment. The overboard exhaust valve will also open if either pack switch is selected to high and the right recirculation fan is off. In the event there is no airflow for equipment cooling, the associated off light will illuminate. If the aircraft is on the ground, the nose wheel warning horn will sound. Selecting the alternate exhaust fan should restore the airflow and extinguish the light. We will now discuss normal air conditioning operation. The air conditioning panel is set up during the pre-flight. Verify that the equipment cooling fans are operating and the equipment cooling fan lights are extinguished. Set the flight deck and cabin temperatures on auto. Place the pack switches in the auto or high position. Notice the slight drop in duct pressure. On the pneumatics panel, verify that the recirculation fan switches are in the auto position, the isolation valve is also in auto, and the engine and APU bleed switches are on. Pack switches should be placed off to start engines. After engine start, position both pack switches to auto and the APU bleed switch to off. These switches remain in these positions until engine shutdown. During the securing check, the pack switches are placed in the off position. We will now look at some abnormal air conditioning operations. A failure affecting the supply of trim air will cause the packs to be controlled independently. If the flight deck trim air is lost, the left pack output temperature will be controlled by the flight deck temperature selector. In this situation, the temperature output of the right pack will be controlled by the cabin zone that requires the lowest temperature. If one of the cabin zone's trim air supply is lost, or if all trim air is lost, the output temperature of the right pack will be the average of the forward and aft cabin temperature selections. Turning off an individual zone switch will cause the temperature control system to operate with the remaining zone selections. In the event of a failure of the flight deck temperature control system, the flight deck temperature will be automatically controlled by the left electronic controller. As you recall, the right electronic controller provides primary control for the flight deck temperature. A failure of the temperature control system for the forward or aft cabin zone will cause the associated trim air modulating valve to close automatically. The cabin temperature selectors still operate normally, but the pack output will be based on the average of the two selections. In the event of a failure of all zone controls and primary pack controls, the standby pack controller will command the packs to produce a temperature that satisfies the average temperature demands of the two cabin zones. In addition, the trim air modulating valves will close. This concludes the presentation of the air conditioning system.